Alright, so what I've done is I've opened up to section 2.8 in the book, the section on the intermediate value theorem, and I've plopped my finger down on a random problem from the book, so I haven't looked at it before, but I just want to guide you through a problem in real time so you can see my thought process from beginning to end. Okay, so the problem says find an interval of length 1/4 in the closed interval from 1 to 2 containing a root of the equation x to the 7th plus 3x minus 10 equals 0. Alright, so when I see this problem, I know I'm going to use the intermediate value theorem, if only because it's in the section in the book on the intermediate value theorem, but also the fact that we're trying to find roots of equations in intervals maybe clues the intermediate value theorem too. So what I'm thinking is I'm going to use the intermediate value theorem, and I'm going to use what the book calls the method of bisection. To cut down that interval from an interval of length 1 to an interval of length 1/4. So I'm expecting that we're going to use the method of bisection twice. Okay. So for the intermediate value theorem, we need a function. It also needs to be continuous, but luckily the function that we have is f of x equals x to the 7th plus 3x minus 10. And this function is a polynomial, so it's continuous. And we also need an interval, which they also give us. They give us the interval 1, 2. Okay. So we're supposed to show that there's a root somewhere in here in an interval of length 1/4 in between 1 and 2. So let's just start by checking to make sure there is a root somewhere in the interval from 1 to 2, and then we'll try to narrow it down to an interval of length 1/4. So to check that there's a root between 1 and 2, we need to compute f of 1, which is 1 to the 7th plus 3 minus 10. So that's 4 minus 10, which is minus 6. And we can also compute f of 2. So that's going to be 2 to the 7th plus 3 times 2, which is 6, minus 10. Okay, and 2 to the 7th, well, let's see, 2 cubed is 8, so 2 to the 6th is 8 squared, which is 64, so I think 2 to the 7th is 128. Yeah, I could have gotten that wrong, but whatever 2 to the 7th is, we know it's quite large, and even without doing out the arithmetic here, I know that f of 2 is positive, right? That 2 to the 7th, even if I was off by a factor of 2, that's pretty big. It's definitely going to dominate this minus 10. So f of 2 is positive, and f of 1 is negative. So this tells us that somewhere in between 1 and 2, the function takes the value of 0, since at 1 it's less than 0, at 2 it's greater than 0. So we know there is a root in the interval that we care about, and now we just need to narrow down where that root is, and we're going to do that by cutting our interval in halves. Okay, so I'll erase this and start doing that. So we're going to cut our interval in halves. So now our intervals look like 1 to 1.5 and 1.5 to 2, right? And we already know that f of 1 is negative and f of 2 is positive. So all we have to do is check f of 1.5. So that's 1.5 to the 7th plus 3 times 1.5, that's 4.5, minus 10. Okay, and so honestly what I'm doing right now is I'm going to go to the calculator and ask what is 1.5 to the 7th. This is not something that I expect you to do in your heads. Raise something to the 7th power. So, okay, if we do that, we get the 1.5 to the 7th is about 17. So we get 17 plus 4.5 minus 10. So, well, again, without actually writing this out exactly, we know that this is positive. Yeah, positive. Right, so now we know f of 1 is negative, f of 1.5 is positive, and f of 2 is also positive. So since our function switches sign between 1 and 1.5, we know there's a root in the interval from 1 to 1.5. Okay. But our problem says that we want an interval of length 1/4, and right now we have an interval of length 1/2, so we're going to repeat this process. So we're going to cut the new interval 1 to 1.5 in half. So we get 1 to 1 1/4 and 1 1/4 to 1 1/2. And again, we already computed what f of 1 was, and we know it's negative, and we already computed what f of 1 1/2 is, and we know that's positive. So we only need to check f of 1 1/4, which is 1.25 to the 7th, plus 3 times 1.25, that's 3.75 minus 10. Okay, and so again, I'm going to go to a calculator and ask what is 1.25 to the 7th. Okay, and it looks like it's about 4.77. Okay, so I have something that's a little bigger than 8, maybe it's like 8.5, minus 10, so that's negative. Okay. So what this tells us is, since f of 1 is negative, f of 1.25 is negative, and f of 1.5 is positive, our function changes sign between 1.5 and 1.5. In other words, it must have hit 0 somewhere in between there. So we conclude f has a root in the interval from 1.25 to 1.5, since f of 1.25 was negative, but then f of 1.5 was positive. We must have crossed 0 somewhere in between there. Great, so that is it. I hope that that was really helpful.